we're going to now start to take an approach where we're going from the broadest strategy to the enabling technology that AWS provides and what that's done, and talk a little bit more about how, as a business, you can operationalize this, which means that you're going to need a number of different aspects of your business working together in order to build these data science-based AI solutions. So a little bit of background on me. I've been with Pariveda now about 9 years, and I have experience over the last 5 years really starting out in the big data space and coming through to AI and machine learning, and now kind of working on more of that digital strategy specific to data and the way companies operationalize data. So if you start thinking about why every company is building a data strategy in order to implement on the key aspect of most digital strategies, I think it helps to start looking back at history. So in 2006, these were the largest companies in the world. You see oil, a couple of conglomerates, and then one technology company there with Microsoft. Fast forward just 1 decade, and the colors start to change on the map. You have the top 4 companies all in the technology space. 1 more year, and they've extended their lead, and in fact, their largest non-technology company on this list retreated and actually wouldn't make the list if we were to reorder these. And now, within the last year, 3 of these companies, if not 4, have gone over the $1 trillion mark at some point during the year. They might not be there exactly right now, but the only companies to become $1 trillion companies in the world have done this on the basis of using data to fuel all of the decisions that are made within their business, or at the very least, to provide the devices that capture all of the data that fuels all of the other data strategy, or the data strategy at other companies, that mainly being Apple, profiting off of that trend as a whole. And if you look at what these companies have done, they use a data network effect cycle in order to build up a larger and larger user base. So by building out new functionality that leverages data to target the right customers, they bring more people onto their products and services. Those people, through the use of those products and services, generate more data, which allows them to then take another loop around the cycle by building new data analytics to target new customers or target their existing customer base in new and interesting ways and cross-sell, upsell new products to those customers, then feeding more data. And I think the other thing that often gets left out when you're going around the cycle here is with those new users also comes more money in order to build more interesting models on top of that data in order to then basically, instead of looking like a circle, you look like a upward moving funnel to the point where you're continually in this virtuous growth cycle. Now, if you take that to its logical conclusion and you look at these companies and the different industries they've entered, so Apple in the cell phone and watch and music industry, or Microsoft moving into the video gaming industry, they have kind of started to remove the need for the traditional players in those industries by focusing in the capabilities of other products into a digital form. Now at Pariveda, we had a talk from a man named Robert Tercek, this is now a couple of years ago, and his conclusion based on this trend was that over time, basically every industry was going to be what he called vaporized, meaning the industry can be replaced with software equivalents, whether that's on a mobile phone through an IoT device, or in the more recent examples, things like the legal profession, or even professions like mine, where you're talking about software development, where I came from starting out as a fresh college grad, are starting to get AI equivalents that can replace a lot of the low end of those industries with a solution that scales better, that enables organizations that didn't have the capability to hire those types of people in the past to get into the game, and fundamentally disrupts the underlying industry. Now, he does a really good job, and you can find some of Robert's talks, or you could buy the book Vaporized, of giving this scared straight, you must digitize your business or understand how you're going to do that, or else someone else is going to run your company out of business talk. Now, in thinking about it as a company, as we kind of digested his opinion, our thinking as a company is that it's really not that bad. And it's because of companies like Amazon and companies like Databricks and others like DataRobot or Algorithmia that have started this trend of making it very easy for every company to get into the game with data science. So if you look at the 4 examples here, and Chris kind of talked to the way that AWS now provides this with the SageMaker Marketplace and the AI as a service offerings that they provide. And these 4, top right is, sorry, your top left is AI as a service. You don't need to know anything, you just call the API, the model's already built, and it returns you results. Then you have the space that's being termed these days auto ML or auto machine learning. This is where you have your own data, but you don't need to know anything about the data science algorithms underneath the hood. It runs all of them in parallel and tells you this one got the best results, just use that. SageMaker from Amazon provides you with the capability to use a marketplace of hundreds of algorithms trained on your own data, a little bit more technical requirements needed there, or technical knowledge needed there, but still not necessarily, for a lot of problems, the full capability to develop a new algorithm from scratch. And then the bottom left category for you guys is companies that enable that ML operation. So Databricks with the ML flow libraries that they have, and Domino Data with the platform they provide, as well as a number of others who have entered this space recently, make it so that when you actually build those machine learning models, it's not extremely complex to take them from that experimental environment and get them out there tied into your app or tied into your website or deployed out on an IoT device, as it was even just 3 years ago. In addition to that, all of the training that you would need to educate your people to use those tools in an interesting way has been provided for free on the internet through the MOOC providers like Coursera, Udacity, those companies, and through the largest technology companies that are out there, because they want you to buy into their frameworks. Amazon wants you leveraging their frameworks and their underlying technology in order to sell you the computational power that is required to actually develop these models. So this is really the first time that I can think of that some of the best training available from the best universities and continually refreshed training, so that when you go and take this course, you're not necessarily going to be 5 years out of date to the state of the art, is all available to any company for free. It's really on the companies then to build the right training program for their people and to leverage the right set of technology. But it's not the situation where this select group of companies that showed up on that first chart, these 5 or 6 companies, are the only ones that are ever going to be able to do really advanced AI technology. Every company these days should be looking at this, because it is now possible for anyone to get the training and the tooling in order to do this in a real way. So a few examples of that Pariveda has worked on over the years to make it a little bit more real. The first one is a healthcare company. So this is actually a hospital, children's hospital, where they were treating a condition that is endemic to pretty much any hospital on earth, but is especially tragic in a children's hospital, where someone shows up sick, is healed through surgery or otherwise, and then contracts an infection while staying in the hospital. Those infections have a 19% mortality rate, especially in this specific case. So this is a central line associated, meaning that you have, the infection is starting essentially in your blood right near your heart. And it's extremely terrifying. Actually, my wife got sepsis once, and it knocked her out for a week, and it was very, very scary. So what the hospital was able to do was leverage all of their EMR data. So not just here's the patient vital signs, but also all of the doctors and the nurses dictated notes of that using natural language processing in order to actually build a model that says these patients, based on recent events within the hospital, are the most likely to get a central line associated bloodstream infection, and then suggest more regular rounds or different changing schedules on their central lines, those sorts of things, to help reduce the incidence rate of those types of infections. So a very human, literally life-saving approach. On the more business-focused side, you can look at companies like oil and gas companies trying to go out and, this is not the company that actually pumps the oil out of the ground, it's the company that sells them the pump. And they were looking to build a sales strategy because this, each one of these deals can make or break the whole year for this company, right? If you can sell one oil field, that's a huge piece of equipment that you've now just sold. And so they needed to figure out, when making a bid against their competitors who are well known in the industry, what is the likely strike point based on not only the current value of this sale, but the likely lifetime value of that customer relationship. If you can get a new customer and they're going to spin up hundreds of oil wells over time, there's more incentive for you to come in at a lower price earlier and make it up on volume. So they needed a predictor, not only using their data, but also what their competitors had bid in similar situations to give them that slight competitive edge. Next one was retail energy. So this is a commodity space. I'm sure everybody, I guess not necessarily here, but in many states, you have people knocking door to door trying to say, hey, switch from your energy provider to this one, you'll save a few cents per year. Everybody's service there is the same energy supplied by the same power lines to your house. And so it's very difficult for these companies to differentiate themselves. So in looking for a competitive edge there, you can combine multiple machine learning models to start to say, hey, we will save you energy by making you aware how much it's going to cost you at any point in time. And so in this model, we were able to predict every individual customer's bill at the end of the month, and then surface that as they went to adjust their thermostat, which this was primarily a Texas-based company. So in Houston, it gets really hot in the summer, and if you want it at 65 degrees when it's 120 degrees outside, that's going to cost a lot of money because everybody wants energy right now. So it would allow you to make those in-the-moment trade-offs. I want 2 degrees warmer because that's going to save me $7, and that's a trade-off I'm willing to make. Not only did that really help their consumers manage their decision-making better, but it also then, on aggregate, helped that company buy energy in lower quantities when it was really expensive, and then use that money to save basically to save their customers money once the overall market rates went down. Final one, I think, is what everybody pictures. When you say machine learning, everybody immediately goes to some kind of equipment, whether that's a giant mining truck or a agronomic harvester machine, and being able to say, it's going to break in this part of the engine in the next, basically harvest season in the ag equipment. Because if that piece of equipment goes down while you're in the middle of operations, that basically can kill a farm in that case, or in a mine, similar situation. You're out in the middle of nowhere. If that truck breaks down, it's going to take a long time to bring that mine back online. So using these machine learning techniques and using the technology that I was just talking through and the training on top of that for these specific types of problems, which you can pretty much find for free, these companies were able to build solutions that leveraged AI to give them that competitive advantage. But underneath of that, what they really needed to do was build it up so that they weren't just doing that one thing. That healthcare company didn't just build a model around central line bloodstream infections. They built many models, and they built up a department within their organization that helps them across both care delivery and their payer side of the business. And so they had to really go through these stages of maturing their organization from just trying to figure out whether machine learning could be applied in their business in what we're calling the forming stage. And you'll see that the stages here map back to the stages of team formation, because it really does actually feel like this as you build up your machine learning capability. For anybody that's newer and still your company is in that forming stage, as you move to that next stage, you're going to build a number of proof of concept type applications that maybe a few MVPs that actually get out into the field, and you're going to start to see the friction that comes from having these kind of probabilistic, non-deterministic models where your organization might be used to just, here's our software schedule, we have the requirements, we build the requirements, we release the software, we do marketing, everything's good. Here it's, maybe it works, maybe it doesn't. What other data do we need to pull back in? The people who first start to use it, start to take these models, do something that you really wouldn't expect them to. See a prediction of the patient is, let's say, 40% likelier than the one next to them to contract an infection. And all of a sudden, that patient is getting 5 times the care. Well, that's not really what the right way to roll this out is. So you end up going through this learning across your entire organization, not only from how do you build these new things in a new way, but how do you use these new predictive capabilities within your organization to change the processes in a controlled and meaningful way. Over time, some of those will be successful. It might not feel like that right at the beginning of the storming stage, but as you come out of that and you start norming, you now have a couple of models for, oh, here is what it looks like when we actually got through a few of these that worked well. Let's take those lessons and move them out to the remainder of our development so that we can start to get that flywheel going for our business, that data network effect moving. And over time from there, you build out the underlying technology to make this a fully capable factory of producing these models at scale. And over time, you end up in the performing stage where your organization understands kind of at its core, or at the very least, within a center of excellence that can be used to help the rest of it. So if that is the core. And that helps you start to make it so that you're focused on executing against a continuous backlog. You're running many production experiments on the different treatments that you could apply based on knowing something about the future and figuring out what the best changes to your business are, not necessarily trying to figure out how to build the models in the first place. So the people on that core team, so we're talking about now the process to build out the team that will develop the models, really is a span of overlapping capabilities. So you start out with people who really understand the business. Your business analysts that are out there actually on the day-to-day, and that could be actual nurses in the field in a hospital. That could be more traditional business analysts in a retail business. Are working with data scientists to transfer their knowledge of what's happening in the real world into an understanding of the data that's been captured to represent that. And like Chris said, that data then writes the code through what I've recently been trying to talk through, and it only works if you really come from a computer science background, data pipelines that are built by a data engineering team. Those are essentially the compiler if the data is the code. That feeds the data through, trains the machine learning model using an algorithm that the data scientist has built, and at the end is deployed out through software engineering. And when Sri comes up in a moment here, he'll be talking through more of the details of how that flow can work within your team. So the way that those people work together needs to be defined as well. So underlying the process, underlying the team is a process of building out that backlog of ideas to go after. This is extremely important as you're just getting started to kind of have the concept that there are many areas where machine learning can help our business. We have not necessarily backlog that is fully fleshed out, but we have several ideas of where we can leverage machine learning, and we pick one or two based on where we think it will help us the most. Oftentimes you're in that going into storming stage, you're looking at a core champion team trying to advocate this to a business community that may be less accepting of the technology. That's changed a lot in the last year and a half, maybe, where people are just a lot more accepting that this is coming than they once were. But that first win needs to be the right win for your organization. If it's people afraid that the technology just doesn't work, then you might go after something easy to do, even if it's not that big of an impact. If it's somebody that thinks this isn't going to make a material impact on our business, then you might be better off going for 3 things that could make a major impact, but have a lower likelihood of success. Now, over time, as you build up to a capability around this area, you'll be able to go for many things in parallel. And so that's where this left-hand wheel starts to turn and churn out the right ideas into a center platform. And again, Shri will hit more details here, that allows you to leverage the technology I was talking about before, leverage SageMaker, leverage the AWS stack, leverage Databricks to build those data pipelines, and leverage MLflow maybe to track your experiments. So you know whether the ideas that you had, we're going to be able to predict the win price for us across all of our large-scale deals at the oil services company. Well, you use all of your historical data, you build up a model that says, yes, we can, with 78% accuracy, predict within $5, or 5%, not dollars, the price that will win versus lose the deal. Then you need to move that into the real world. You need to actually get that deployed out as a service and to put into your CRM application so it's surfaced to your salespeople throughout the sales cycle. And that last wheel starts out churning pretty slowly. And over time, what you see is this kind of locomotive effect where you have a flywheel of ideas in the back driving a somewhat smaller number of experiments, driving the overall realization of value on the right. If you look at this by double-clicking on it really quick, there's a lot more detail that needs to go in behind those loops in order to actually have a process in that norming and performing stage that will allow you to run that type of organization at a scale where you have many teams going after many ideas at the same time. Not planning to drain this, happy to talk more about it. Now, that's all great. So all of the things that we just talked about get you to the point where you can build models in a meaningful fashion by having people collaborate to bring the data in, determine whether there's value in the data, and push things to production. If you really want that locomotive to be able to move, though, you need the tracks that it's going to drive along. And so that's where data engineering comes in. Now, what I have up here is a picture of the Lascaux cave paintings. So Chris cannot answer this question, but anybody else here know what the Lascaux cave paintings are?
They're a set of paintings in France from prehistoric times.
Yep, that's right. So they are basically the first time, if you think about it, that humans ever recorded data. They drew a picture of their surroundings on the walls of some caves, and it's still been preserved to this day. So 20,000 years later, we still have these paintings. Now, technically, anything you put in Amazon S3 should be there 20,000 years later as well, based on the 11 nines of durability. So we'll see. But what's interesting these days is literally anything can actually be converted into data that can be used in these machine learning models. So this is if you run through kind of the automated image recognition technology that's out there freely available to you as a service on the Lascaux cave paintings. They tell you that it actually is the Lascaux and it's in Chauvet Cave, and that what's pictured there, all I guess is cut off, is some fauna and flora and some organisms. So you were able to actually take the oldest data ever recorded by humans and make that into actually machine learning ready data, which is, I always find pretty amazing. But if everything in your entire world can be data, that means that you're going to have the 3 V's problem, which if you hear the term big data, everybody always refers to volume, velocity, and variety of data. Tons of it, it's coming. And what do you need to do in order to handle that? You need to build a data lake. And so I kind of talked about before that data is the new oil that companies are built on top of. And this is my favorite picture of a data lake. So data is the oil, and here it is in a lake. It's sitting there, and It's literally useful to no one. So this is an old oil field. They pumped the oil out of the ground, and they had so much of it, and they couldn't get it out of there, so they just started pooling it. And that's really what your data lake is right now. You just handle the 3 V's of data because you can convert every image in the world into data, and you don't go through the process to figure out how to use it. Well, now what you've got is basically a big pit of oil. And so the value of a data lake isn't really anything until you start to build out the technology to move data from that lake into the process that we defined earlier in order to actually build, whether that's machine learning models or dashboards or canned reports that are shipped to people in Excel. That engineering platform needs more components than just the 3 V's of big data. You have to focus on the veracity of the data. This is one of the differences between, maybe not, between oil and data. Oil, I guess, could be dirtier and you have to refine it more, but in the same way that data can be dirty and somewhat unusable. And then we talked a lot before about how do you actually find the value in data to drive what you want to build on top of it. So your next step from there is to start building out data pipelines. If you have data pipelines in place, as that torrent of data comes out from the world and you're capturing it through the mobile phones and IoT devices and click streams that you have on your website, you can start to, in much shorter order, build the infrastructure to take that and convert it into a product, to build those plastics or gasoline conversions and ship those to your end consumers. But one data pipeline, and if you just build one data pipeline for every new stream of data that's coming in from the world, and you have to rebuild it from scratch every time, you're going to fall way behind really fast. And so what you really need underlying that is the infrastructure to enable you to quickly build data pipelines. So there's a number of enabling technology capabilities that are provided by companies like Amazon, like Databricks, as products that you can buy much of this functionality, although you'll still have to configure it for your organization. And that gives you a set of capabilities as an organization that can drive a set of outcomes around the data that you're bringing in. So you have visibility of that data, you know where it is and what is within it. You have quality assurances that you're not necessarily bringing through mud, you're bringing through much cleaner, refined data products, and so on, in terms of building out the underlying business capabilities that you don't make bad decisions based on bad data, or you don't run into a situation where you've built so many data pipelines that you just have this spaghetti mess and no one can actually figure out how to do anything anymore. So in order to build those enabling capabilities, you also need the dirty word, governance. Everybody shudders when you say governance, which is why I've actually stopped saying governance recently, and started to talk about data operations. It's a much more understandable concept for people, and it's really the way that this is starting to be done. This is really over the last year. People have started to focus on governance as something you do within the development process. So within the 3 circles there, you're applying techniques that put tests on top of your data in real time, not in real time, but as you're actually developing those data pipelines, you know along the way that everything is right. You don't wait till the end and then convene the governance council and yell at everyone for not having clean data. You also start to focus on, so that's the governance is not a project. You also need to start to focus on experimentation within this platform. So I showed you a lot of production data pipelines that flow from the oil sands in Canada down through America to the Gulf Coast or something like that. But how do you know that that's the right path to build your pipeline on? Well, you need to actually figure out where you need that data to flow to first, and that's where experimentation comes in. So underneath of your pipeline, you might need to build an experimental pipeline that isn't built on the full version of your exactly what it's going to run in production on. You're just trying to have a data scientist in a notebook in SageMaker or in a Databricks notebook, tinkering around trying to figure out how do I take all of this raw information that I have and build something useful for the business on top of it. At which point you can then kind of follow that arrow around, and make the production version based on what you determine to be the right routing of that pipeline in the experimentation phase. So it might feel like a lot in order to, if you're just kind of getting started in this space, to take your organization and go all the way out to a full data platform with a big team running a complex process in parallel across 14 teams all building on top of the hundreds of new data streams. But you don't have to start there. It's really start with bringing in 1 or 2 new data sets, finding those right first problems to go after, building this experimentation platform, building a prototype, and getting that out there to prove the value of machine learning in your organization. The rest of this can all be layered on over time to build up this capability from the ground. Now, the last piece of this talk usually goes into a fair bit of detail around how do you actually take the data science components, so the modeling, predictive modeling, and get that out into production. But luckily, we've got another talk today that's also going to be focusing on that. So I'll give you guys the really simple version of it to start. So in order to operationalize data science, you heard me talk about it before, that it starts with the idea generation and picking the right things that actually will drive results for your business over time. But it also needs to include that last jump of the 3 circles, that jump from the experiment into the deploy, test, and run needs to be there as well. And so if you take the 3 circles and refocus it on one single idea, you really got 5 stages. You've got figuring out that it exists as an idea, building a prioritization that picks the right ideas for you, making sure those ideas are feasible through a prototype, and then this last step of getting it out there to market test it. That might be internally within your business, but getting something to some smaller user group and figuring out what the right things to do are based on that new predictive capability. And then finally, if that actually shows the right results, or really once that actually shows the right results, because it generally takes a couple of tries. For instance, the smart thermostat thing, we initially built it where we would just show you that's going to cost you $7 more in order to turn your temperature down 2 degrees. And what we found is it actually didn't drive a ton of behavior. People are like, $7, whatever. But if it was showing the total bill prediction for the month, and it said your total bill will now be $147, people are like, I don't need to spend $147 on energy this month. So those are the types of things you end up finding in a market test. But in order to enable that market test, you need to get the actual machine learning model tied into that app or tied into that smart thermostat. So there's one more step, which is really the deployment cycle. So, right, you've got an app and I need to get a prediction of my new customer's bill. So you build the machine learning model, you stand up an API using SageMaker's model deployment service, or maybe MLflow pushes straight out to SageMaker's model deployment service, and then now you have predictions. Over time, those predictions get worse and worse, and eventually that model starts doing bad things because the way that people are pricing their energy changes, the way that companies are pricing their energy changes, or consumer behavior changes over time, and you trained this data on model on data from last year. So at that point, it's relatively simple these days to just take the data that you've been accumulating over that last year and retrain a new model, and then deploy it out, and everybody's happy. But in the real world, it doesn't actually end up that simple. You end up with lots of models that chain together and lots of experiments to manage across, when we combine this version of this model with that version of that model and a third predictor and then this version of the app, this is the result we get. And so you get these complex, scary scenarios. And that's why you need more modern experiment management tools, which I think is a great intro to bring Shri up here to talk you through some of those tools and the implications they have.